Yes, starting with the second chapter of organic chemistry. This chapter includes alcohols, phenols, and ethers. Properties of alcohols and phenols preparation will be taken up together, and ethers will be separately taken up after we finish alcohols and phenols. So first write down alcohols and phenols. Alcohols and phenols. Write down both contain OH group called hydroxyl group. Hydroxyl group. So if it is attached to the carbon atom of an open chain or a non-aromatic ring, it is called alcoholic group, and compounds are called alcohols. Compounds are called alcohols. So if it is directly attached to the carbon atom of an aromatic ring, it is called phenolic group, and compounds are called phenols. I'm writing few examples on board. You need not copy. If you want, you can, but there's no need. First three are examples of alcohols. Open chain, aromatic ring is present, but OH is not attached directly to the aromatic ring. This ring is non-aromatic. So first three examples are alcohols. Last example is a phenol because OH is directly bonded to the carbon atom of aromatic ring. Right, the first heading is structure of the group. Structure of the group. Right on A part. Alcoholic group. You just have to copy from the board. Carbon sp3, oxygen sp3, carbon oxygen and hydrogen bond angle. This angle is 108.9 degree. Oxygen hydrogen bond length 96 picometers. Carbon oxygen bond length 142 picometers. You have written almost everything about the structure of the group. You have to write just one small sentence. See, if there is sp3 hybridization, bond angles are expected to be 109.28 degree, but in this case, bond angle is slightly less than 109.28 degree. Why? If you remember, in 11th you studied, this is due to LP-BP repulsion. Right on. COH bond angle is slightly less than 109.28 degree due to LP-BP repulsions, lone pair bond pair repulsions. Next, write down B part. B part, phenolic group. Phenolic group. Again, draw from the board. Oxygen, sp3 hybridized. This alpha carbon, sp2 hybridized. This bond angle almost same as in case of alcohol, 109 degree. This bond length is 136 picometers. 136 picometers. You have to write just one sentence about this bond length. In alcohols, it is 142. In phenols, it is slightly less. Why? Write down. OH, sorry, CO bond length in phenols is slightly less than in alcohols because it has partial double bond character due to resonance. We already done resonance of phenol in alkyl and aryl halides. There I told you the bond between carbon of aromatic ring and oxygen. It has a partial double bond character, and that's why this is slightly shorter than the pure single bond. Next heading, next topic, classification of alcohols and phenols. Will be really fast in classification because all basic things we already done. Right on number one. On the basis of number of OH groups present in the molecule, they are classified into monohydric, HYDRIC, monohydric, dihydric, and polyhydric compounds. So it's so simple, there's no need to give an example, but be very careful. If you are giving the example of a dihydric or trihydric alcohol or phenol, remember, do not attach more than one OH group on the same carbonate. That, of course, you have to keep in mind. Number two, second classification. Classification based on hybridization state of carbon atom to which OH group is attached. within brackets write down this. This classification is for monohydric compounds only. So you'll find it easy because if you remember, we did allylic, benzylic, vinylic, everything we did in halides. Same thing will be repeated here. That on capital A part. This will take up in two parts. Capital A. Compounds containing bond between OH group and sp3 hybridized carbon atom. sp3 hybridized carbon atom. They are further classified into four categories. Now numbering will be small a, b, c, d. That on A. Alkyl alcohols oblique alkanols. That on R. Those compounds in which OH group is attached to sp3 hybridized carbon atom of a saturated aliphatic chain. Aliphatic means open chain, called alkyl chain. Their general formula is CnH2n plus 1 OH or ROH. They may be primary, secondary, or tertiary. Almost nothing to explain. You'll find it easy. Maybe primary, secondary, or tertiary. For example, this is tertiary alcohol. This is secondary alcohol. Primary alcohol. B part, small b, remember that. Cycloalkyl alcohols oblique cycloalkanols. That are those in which OH group is directly attached to the carbon atom of a saturated alicyclic, alicyclic, oblique, carbocyclic ring. Alicyclic or carbocyclic means the ring made up of carbon atoms only. Alicyclic or carbocyclic. And you have written saturated means all the bonds should be single covalent bonds. Their general formula is CnH2n minus 1 OH. CnH2n minus 1 OH. They may be secondary or tertiary. They cannot be primary, secondary, or tertiary. For example, this is tertiary. And this is secondary. Third category, C part, small c. Allylic alcohols, ALLYLIC. Now, once you know what are allylic, it will be easy for you. You know allylic carbon atom. Allylic alcohols are those in which OH group is attached to allylic carbon atom. Allylic carbon atom. They may be primary, secondary, or tertiary. They may be primary, secondary, or tertiary. For example, let me test whether you remember or not. Can you tell me how many allylic carbon atoms are present? Anyone? How many allylic carbon atoms?
2.
2.
2.
Yeah.
2 is correct. Start from the left. Tell me carbon number.
1 and 4.
1 and 4. These are allylic carbon atoms. If you attach OH group to any one of them, that will be allylic alcohol. And if I attach here, it becomes secondary allylic alcohol. So note down OH, and then this is secondary allylic alcohol. This is primary allylic alcohol. This is secondary allylic alcohol. Similarly, you can make an example of tertiary allylic alcohol. D part. Benzylic alcohols. Benzylic alcohols are those in which OH group is attached to a benzylic carbon atom. Benzylic carbon atom. They may be primary, secondary, or tertiary. Benzylic carbon. Which one? sp3 carbon directly bonded to the aromatic ring is benzylic carbon. And this one is secondary. So this is secondary benzylic alcohol. Primary benzylic alcohol. Secondary benzylic alcohol, right? Similarly, you can make the example of tertiary. So these were four categories in which OH group is bonded to sp3 hybridized carbon atom. Next item, capital B part. Capital B. Compounds containing bond between OH group and sp2 hybridized carbon atom. They are further of two types. A part, small a, vinylic alcohols. Vinylic alcohols. That are those in which OH group is attached to a vinylic carbon atom. Vinylic carbon atom. They may be primary or secondary. So they can only be primary or secondary, they cannot be tertiary. For example, if I want to make it a secondary vinylic alcohol, tell me from the left to which carbon number should I attach OH group?
Three.
Hmm?
To carbon number 3.
Yes, these are two vinylic carbon atoms. This is secondary, this is secondary. You can attach to any one of them. This or this, secondary. This is primary vinylic alcohol. This is secondary vinylic alcohol. B part. Phenols. Phenols are those in which OH group is directly attached to carbon atom of an aromatic ring. Aromatic ring. For example, two benzene nuclei fused together, that is naphthalene. Naphthalene is also an aromatic compound. If you attach OH group to any one of these carbon atoms, that will be an example of a phenol. This is naphthol, right? So these are phenols. Next topic, nomenclature. And we'll finish nomenclature today. Since you already know about normal, secondary, neo, tertiary, it will be easy for you to understand. We can go a bit fast. Nomenclature. That on A part, monohydric alcohols. So in the A part, we are taking up nomenclature of monohydric alcohols. Copy from the board. General common names. General common names. In general, in common nomenclature, what do we call them? They are called alkyl alcohols. Alkyl alcohols. General IUPAC. Alkanols. Alkanols, you know, ethanol, methanol, butanol. So that is general IUPAC name. Now we'll take up examples. We'll follow the same pattern on the extreme left, structures, then common name, if any, and in the extreme, on the extreme right, IUPAC name of the compound. First two compounds, although you'll find very easy, but you should know common names. CH3OH. It has three common names. Methyl alcohol, like alkyl alcohol, methyl alcohol. Oblique, second common name, wood alcohol. Wood alcohol. Oblique, third common name, wood spirit. So I'll repeat, methyl alcohol, wood alcohol, or wood spirit. Why do we call it wood alcohol or wood spirit? Because industrially this is obtained by the destructive distillation of wood. IUPAC, very easy, methanol. Methanol. Second, two common names. One is ethyl alcohol. Ethyl alcohol. Second common name, alcohol. The only word alcohol, because amongst monohydric alcohols, this is the most important alcohol. So if we simply say alcohol, we are talking about this alcohol, not any other alcohol. IUPAC, ethanol. Ethanol. Now you will help me in common nomenclature. Yes, tell me. Keep on noting down, and anyone please tell me what's the common name.
Isobutyl alcohol.
But come closer to the mic, please.
Isobutyl alcohol.
No.
Sorry.
Secondary butyl alcohol.
Secondary butyl alcohol. And one thing more, please. In case your answer is wrong, no one knows who answered. So you must try. No one knows. Even I don't know who answered. So this common name is secondary butyl alcohol. This is not isobutyl. This is the secondary carbon. Remember, only that iso which has three carbon atoms is secondary. Otherwise, all isos will be primary. This has four carbon atoms, so cannot be iso because OH is attached to a secondary carbon atom. Anyways, common name secondary butyl alcohol. IUPAC name, you can see the arrow, 2-butanol. 2-butanol. Yes. Common name. Try. I'm ready for the wrong answer. Please try.
Isopentyl alcohol.
Good. This is isopentyl alcohol. Isopentyl alcohol. This is the longest chain in direction. IUPAC 3-methyl 1-butanol. 3-methyl 1-butanol. Next. What is the common name?
Neohexyl alcohol.
Neohexyl alcohol. Neohexyl alcohol. In this direction, IUPAC 3,3-dimethyl 1-butanol. 3,3-dimethyl 1-butanol. Common name.
Dirt.
Third
Dirt
pentyl
propyl.
alcohol.
Now common
Sorry,
name.
propyl.
Now common name.
Third
Dirt
butyl
butyl
alcohol.
alcohol.
Pentyl. Right? We count all the carbon atoms. So note down this one. Common name tertiary pentyl alcohol. Tertiary pentyl alcohol. This will be the direction of counting. IUPAC 2-methyl 2-butanol. 2-methyl 2-butanol. One more example. Tell me the common name. You can do it.
Benzyl alcohol.
Sorry?
Benzyl alcohol.
Benzyl alcohol. BENZYL, benzyl alcohol. Even IUPAC you can try. Let it be wrong.
Phenyl methanol.
Chlorophenyl methyl.
This is phenyl methanol. Let me tell you. You know this compound is methanol. Replace one hydrogen by phenyl. Replace one hydrogen of methanol by phenyl, it becomes phenyl methanol. So IUPAC name phenyl methanol. Now Radam B part. Dihydric alcohols. Dihydric alcohols. General common names. Glycols. GLYCOLS, glycols. So any such open chain compound, open chain and saturated compound, which has two OH groups, will be called a glycol in general. General IUPAC. Alkane diols. This is one word. Alkane diols. For example, CH2OH, CH2OH. See, two OH groups are attached to adjacent carbon atoms. It means this is a vicinal compound. Think of common name of vicinal dihalides. Think of common names of vicinal dihalides. On that basis, you can name.
Ethylene glycol.
Yes, Vicinal alkylene. In place of dihalide, we'll use the word glycol. Ethylene glycol, or you pronounce it ethylene glycol. So common name ETHYLENE, ethylene glycol. If I say amongst glycols, this is the most important glycol, then the second common name is glycol. Second common name, glycol, because this is the most important amongst glycols. IUPAC name. Remember, IUPAC name with or without numbers will be correct. We can say ethane diol, we can say 1,2-ethane diol, we can say ethane 1,2 diol. Positions have to be 1,2, positions cannot be 1,1. Therefore, even without numbers, IUPAC will be correct. So IUPAC name, ethane diol. This one is propylene glycol. Propylene or propylene glycol. IUPAC 1,2-propane diol. 1,2-propane diol. There are 5 carbon atoms in a straight chain. Even this you can name. Common name?
Pentylene glycol.
No. Pentylene तब use होगा when 2 OH groups are on adjacent carbon atoms. ये कुछ और है. Something else. Anyone? Okay, I'll give you a hint. 5 CH2s. What is CH2 called in common nomenclature? Come on.
Sir, is it methylene?
Yes. How many? 5. So common name, pentamethylene glycol. Penta means 5, methylene means CH2, glycol means 2OH. So common name, pentamethylene glycol. IUPAC 1,5-pentane diol. 1,5-pentane diol. C part. Trihydric alcohols. Trihydric alcohols. General common names. They are called glycerols. 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 General IUPAC. Alkane triols. Although you can take any number of compounds, but in this category, one compound is very important. So we'll take only one example. This is CH2OH, CHOH, CH2OH. Common name, glycerol oblique glycerine. Glycerol or glycerine. You all might have used glycerine at home. IUPAC with or without number, IUPAC will be correct. IUPAC propane triol. propane triol or 1,2,3 propane triol. That is your choice. Now, last category, D part, phenols. In phenols, there is no general common or general IUPAC name. If there is any common name at all, every compound will have a special common name. For example, common name carbolic acid. Due to its acidic nature, this is called acid in common nomenclature, carbolic acid. IUPAC name phenol. Phenol. What are these positions? Ortho, meta, or para?
Meta.
This is meta cresol. One methyl and one OH group, common name cresol. This one is metacresol. Similarly, can be orthocresol or paracresol. OH is given more preference. This is 1, this is 3. IUPAC name 3-methyl phenol. 3-methyl phenol. These positions, very simple, para. Common name para-nitrophenol. Para-nitrophenol. IUPAC 4-nitrophenol. 4-nitrophenol. We can make this common name more complicated. We can also call it para-nitrocarbolic acid. I hope easy to understand. On the basis of first compound, carbolic acid, this can also be called para-nitrocarbolic acid. Anyways, that is rarely used. In many compounds, prefix ortho, meta, para is not used. They are given special common names, like this one is salicylic acid. SALICYLIC. Salicylic acid. Now, COH group is given more preference. It means OH group is at carbon number 2. Since OH is a secondary substituent, we'll use the prefix hydroxy. So IUPAC name 2-hydroxy benzoic acid. 2-hydroxy benzoic acid is the IUPAC name. But you should know even benzoic acid is not IUPAC name. Sometimes common name becomes so popular that it is accepted in IUPAC nomenclature. Like benzoic acid is the common name, but it is so popular that it is accepted in IUPAC nomenclature as well. Otherwise, you should know that actual IUPAC name of benzoic acid is benzene carboxylic acid, right? So on that basis, its more precise IUPAC name should be 2-hydroxy benzene carboxylic acid. But anyways, don't worry, 2-hydroxy benzoic acid is also correct. Next example. CHO. Earlier it was salicylic acid. Now this is salicylaldehyde. SALICYL aldehyde. Salicylaldehyde. IUPAC 2-hydroxybenzaldehyde. 2-hydroxybenzaldehyde. Now I'm writing last 4 examples. Last 4. All of them have special common names. No ortho meta para. Special common names. First one, common name CATECHOL. CATECHOL, we pronounce it catechol. Catechol. IUPAC will take up later on. Catechol. Second, resorcinol. RESORCINOL. Third one has 2 common names. One is phenol. Phenol. Second common name is hydroquinone. Hydroquinone. Last common name pyrogalol. Common name is pyrogalol. Now, if I tell you the IUPAC name of one of them, you'll be able to write IUPAC name of all the 4. First one is benzene 1,2-diol. Benzene 1,2-diol, or you can say 1,2-benzene-diol. It means remaining are clear. Next, 1,3-benzene-diol. Next, 1,4-benzene-diol or benzene 1,4-diol. And last will be 1,2,3-benzene-triol. That's all for today. Next time we'll start